Good evening, students. So, welcome to APJ Academy. So, hope you have watched the previous class, and today we will be discussing the new topic from the chapter Atomic Structure, that is hydrogen spectrum, which is an important topic from atomic structure. In the last class, we have discussed about the Bohr model. Hope everything was clear for you. Hope the concepts were clear for you. So only if that is clear, then only you will get a clear knowledge about what we are going to discuss today. Okay. So this is let me give an introduction regarding our courses. So we have a full year course. Okay. And in that course you can see that we provide the PDF materials. There will be test series which will be 25 major tests as per the NTA pattern. Okay, so there will be query solving will be there, and we gives you or provides proper lessons, and assignments will be properly reviewed by our mentors. And we have mentorship program. You will be assigned with a mentor to look after your studies. If there is any problems with any subjects, they are ready to help you out and clear all your doubts, and they'll always keep you motivated, because that's a very important factor as we do our repeat classes, or as you are taken a drop, and if you are a repeater or if you are a going student, it is always very important. Once you are attending a competitive exam, it's very important to keep yourself motivated. So that's what we normally does with the mentorship program. Okay, now next thing is, yes, you can crack JEE or NEET with this enormous discount of just rupees 490 per month. Okay, that's a very good chance for you. So don't miss it, utilize it, and with the small price you can crack JEE entrance as well as the NEET entrance exams. So if you are new to this channel, please subscribe to this YouTube channel, because this will add value to you. It will help you clear your concepts. It will help you in your preparation for the upcoming exams. We are providing regular free classes on YouTube, so this will be very much helpful for you. So don't forget about that. Please subscribe to the channel and also share the link with those of your friends to your friends, those who are preparing for NEET as well as JEE. Right. So that's all about me. My name is Roshan, and I am a MTech postgraduate, was a National Olympiad winner, 6+ years of experience in this field. Yes, now we are going to start the new topic from the very important chapter Atomic Structure, and we are going to discuss about the spectrum. Okay, so first we will discuss what do you mean by spectrum actually. Okay, if you are going into the classification of spectrum in NCERT textbook, you could see that there are two types of spectrums. One is emission spectrum, the other is absorption spectrum. Actually, what does a spectrum means? See, here this spectrum, hydrogen spectrum and all, is based on the Bohr model. So in the beginning also I have told that while taking the class regarding the Bohr model, that Bohr model is only applicable for those species which have one electron. So hydrogen is the only atom which has one electron. There are ionic species which have one electron, but hydrogen is the only atom which has one electron. So we discuss the spectrum in terms of hydrogen atoms. So here the point is, what do you mean by spectrum actually? It is so simple. If you pass some energy through a solution or through hydrogen atoms, okay, the hydrogen atoms or the electrons present in the atom will absorb this energy, and certain amount of energy will be unabsorbed by the hydrogen atoms, and these energies are collected, or these are trapped by a photographic plate which is placed behind this sample, and we could see that there are certain patterns. There are certain patterns, and some patterns are visible with our naked eyes, and majority of the patterns are not visible through our naked eyes. We require certain instruments to see these patterns. Actually, what does this pattern indicates? This pattern indicates that these are the energies which has been passed through the hydrogen atom solution. Okay, so I'll just give you a briefing by drawing a figure. Here you can see that. Let's see, this is the sample I take. Okay, this is the sample. In this sample we contain lots of hydrogen atoms. Okay, lot of hydrogen atoms are present. So I am passing certain radiations, not one, many radiations are passed through this atoms, hydrogen atom sample. Okay, and some of the energies or radiation means it is photons or energy. Some of the energy is absorbed by the sample, and some of these energies get passed through this sample, right? And we have placed a photographic plate over here. This is the photographic plate. Okay, in the photographic plate we have seen a photograph, or we call it as a pattern. That pattern may consist of visible lines. It is normally this pattern is of lines. Okay, there will be visible lines may be present. There will be certain lines which are not visible with the naked eye, so we have to look through the certain optical instruments to identify what pattern is present. So actually this pattern is called as absorption spectrum. Because why I call them absorption spectrum means certain energy have been absorbed, or certain radiations have been absorbed by the hydrogen atoms, and some has not been absorbed, and those which are not absorbed by hydrogen atoms have been trapped, and this trapped spectrum or pattern is called as the absorption spectrum, because we obtain this pattern only because of the reason that hydrogen atoms have absorbed certain what you call energy or absorb certain radiations. Okay, now you have to understand this concept that if hydrogen atoms, so we got the absorption pattern or the absorption spectrum, we got it. I hope that concept is clear for you. Now we know that we have a nucleus and we have one shell, and we have infinite number of shells in hydrogen atom. In any atom we have infinite number of shells. This normally the students think that in an atom there is only valence shell. After valence shell there is no shells. That is wrong concept. There are infinite shells present in an atom, but we only consider valence shell because the final electron is present in that shell, so we only consider about valence shell. So you have to remember that there is not only valence shell, beyond valence shell there are many shells. So first shell is the valence shell of hydrogen. There are many other shells, right? There are infinite shells. So what happens when the radiation has been absorbed? Who is absorbing this? Actually the electron is absorbing. So what happens to the electron? Electron will excite to the next energy level. Yes, electron get excited to next energy level. Here it stands. We know that the corresponding spectrum we have obtained, that spectrum is called as absorption spectrum. Now what happens when an electron is excited? When the electron is excited, after a fraction of second or a certain time, this electron will jump back to the normal state or the ground state. And for jumping back to the normal state, what it does is that it releases certain energy. It releases certain energy. This is a representation of energy. Okay, and this energy is trapped in another photographic plate, and we obtain what? And we obtain, okay, let me maybe this will not be visible for you, and we obtain a pattern, and that pattern is called as emission spectrum. So this is the photographic plate. Photographic plate. Okay, so that is called as the emission spectrum. So what is the difference between absorption spectrum and emission spectrum? Absorption spectrum is obtained when an electron from the ground state get excited to the higher energy state. That's where we obtain the absorption spectrum. What is emission spectrum? Emission spectrum is the energy or the radiation we obtain or we trap with the photographic plate when an electron from higher energy shell jumps back to lower energy shell or its ground state. So this is the difference between emission spectrum and absorption spectrum. Hope this is clear. So I'll again explain what absorption spectrum is, because that's very important, because many students do not understand this point. See, we take a sample of hydrogen atoms, we pass certain radiations through that hydrogen atoms, and we know that certain radiations have been absorbed by the hydrogen atoms and some have been collected on the photographic plate which are not absorbed by the hydrogen atom. So those frequencies or those radiations which are not absorbed by the hydrogen atoms is considered as the absorption spectrum. Why they are considered? Because those radiations which the hydrogen atom does not absorb have been already absorbed by the atoms. That's why it does not absorb the same frequency again, or same energy or same radiation again. That means it is similar to, or it is actually the same radiation that has been absorbed has been passed through the solution or passed through the hydrogen atoms without absorption. So hope that is clear for you. So that is called as the absorption spectrum. And regards with the emission spectrum, I told you that emission only takes place when the electron from higher energy shell jumps back to the lower energy shell. So once it jumps back to the lower energy shell, it radiates, and this is the photographic plate, and in the photographic plate we collect certain patterns regarding to the energy it radiated. Okay, there will be certain lines which are visible, there will be certain lines which are, there are many lines which are not visible, which can only be visible through the through the electronic devices. Okay, so this is as a whole you have to understand regarding the emission spectrum and absorption spectrum. Absorption spectrum is obtained when the energy is absorbed by the electrons of hydrogen atom and it jumps from lower state to higher state. And emission spectrum is the spectrum obtained when the electron from the higher energy shell jumps back to the lower energy shell. Okay, so that's the difference between emission spectrum and absorption spectrum. Now you have to note this. See, there are certain spectrum of sunlight. Okay, and you have to understand that the spectrum of sunlight is a continuous emission spectrum. What do you mean by continuous emission spectrum? You know that VIBGYOR, right? See, if violet, indigo, blue, green, yellow, orange, red, okay, you will see a band like this: violet, indigo, blue, green, yellow, orange, right? In the rainbow you see a certain thickness of the line. Each line has certain thickness like a band, and you always see that this is continuous. There is no gap between violet or indigo or blue. There is no gap. That means the spectrum of the sunlight is continuous, and we can see, and this spectrum, this rainbow, can be seen. There are many other spectrums produced by the sunlight, but this rainbow is the spectrum which are visible. Okay, so each color represent different energies, different radiations, different frequency or wavelength of light. Okay, but what does that express to us, or what does that tell to us, is that these are energies which are visible energies. Okay, these are radiations actually which can be seen as a light, as a color. This is what you have to understand from Absorption. And this happens, you know that when does this happen? This happens when the sunlight travels through the humid climate. We can see this spectrum or the spectrum of rainbow, and there is physics in it, and you can learn that. Okay, I'm not going into that topic, but just understand the spectrum of a sunlight which we see with our visible eyes is the rainbow. Okay, now coming back to the second point, the spectrum of hydrogen atom is line emission. You have to understand the spectrum of the hydrogen atom is like lines. It's like lines, not like bands of rainbows. It's like lines. Okay, and it is also discontinuous. You will see a gap between two different spectral lines. You will see a gap between two different spectral lines. That means it is what? It is, they are discontinuous. But in the case of rainbow, they are continuous. Soon after violet, you will see this band of indigo. Soon after indigo, you will see the band of blue. Likewise, it goes, they are continuous, and whereas the hydrogen spectrum is discontinuous. After one line, you will see a gap. Another line, you will see another gap, and like that it goes. Now, here first we are going to discuss about the emission spectrum. So let's look what emission spectrum is. Okay, yeah, till now I hope everything is clear for you. So I'll keep my mobile phone on the side and just look here. See, we'll start with the first shell, that is, we have a K shell, then we have L shell. We have 7 shells. Okay, K, L, M, because in a periodic table there are 7 periods and each period corresponds to one shell, and since 7 periods are present in the periodic table, that means there are 7 shells. So K, L, M, N, O, P, and Q. So these are the 7 shells. We know that there are infinite shells present in each atom, but normally we only consider about the valence shell. That means the last electron, the shell in which the last electron is occupied. That's what you have to understand. Okay, so we are discussing about the emission spectrum. You have to understand the emission spectrum is only obtained when the electron from the higher energy shells jumps to the lower energy shell. Okay, so you have to understand this is our first shell, K is our first shell, L2, M3, N4, O5, P6 and Q corresponds to the 7th shell. See, we will start with the first one. That means from the 7th shell, if the electron jumps straight to the first shell, okay, that is one corresponding case. There can be such an energy can be released if the electron from the 7th shell jumps to the first shell. Then there is also possible that from the 6th shell, an electron can jump to the first shell. From the 5th shell, electron can jump to the first shell, and all these correspond. See, you can see that from 7 to 1 I have drawn a line, and that line is the spectrum correspond to that jumping. Okay, that means when the electron from the 7th shell to the first shell, when it jumps, it releases energy and we get a line spectrum. That line is denoted as this. Okay, so that is what you have to understand. And if the electron jumps from 4 to 1, we got another one, from 3 to 1, okay, from 2 to 1. Okay, so here you can see that there are 6 lines present, and these 6 lines have one thing in common. What is that? Every line has been jumped from higher level to the first shell. So any emission spectrum which we obtained When an electron jumping from higher energy shell to the first shell, then that spectrum or that series is called as Lyman series. Lyman series. Okay. Similarly, this is Lyman series. Similarly, a jump from higher to the second shell is possible. Now, from 6 to 2 is possible. From 5 to 2 is possible. 4 to 2 is possible. And 3 to 2 is possible. So, there are 3, 4, 5 lines. So, in the first Lyman series, there are 6 lines. And this series is called as the Balmer series. Balmer series, where the electron jumps from higher shell to the second shell. So the lines we obtained here is called as the Balmer series. Balmer series. And you have to understand this Balmer series is the first series we discovered. You know why? What is the reason? Because these series are visible region. That means we can see the color of these lines. The colors are visible with the naked eye. That's why we call them, we say that these are the series which have been observed or discovered first. Okay. Now we can again go back and come up with another series where the line starts from higher energy shell and it stops at the third shell. So that is the first line. This is the second line, this is the third line, and this is the last line. So it consists of 4 lines, and this series is called as the Passion series. What do you call? You call it as Passion series. Okay. Then another series here, 1, 2, and 3 lines, and this, that is from higher energy shell to the fourth shell. That is called as the bracket series. This is called as the bracket series. Bracket series. Now we can again draw one more series, that is from Q to P, or Q to O, 7 to 5 and 6 to 5. And this is called as the fund series. Fund series. There is one more is present, that is from 7 to 6, which is called as Humphrey series. Humphrey series. So these are the different lines, spectral lines or emission lines which we obtain. So in the Lyman series, you can see that there are 6 lines are present in the Lyman series. In the Balmer series, there are 5 lines. In the Passion series, there are 4. In the Fund series, there are 3. Sorry, bracket, there are 3. In Fund, we have 2. And in Humphrey, we have 1. And what you have to understand is that Lyman series is at the region, it is a UV region, or it is ultraviolet. Radiations are ultraviolet, okay, which are not visible. Obviously, ultraviolet is not visible. And Balmer series is the only series which the lines can be visible with our naked eyes. So there are 3, 4, 5 lines which are visible, and that is present in the Balmer series. And all the other 3, that is in the Passion, bracket, Fund and Humphrey, all these lines are IR lines, infrared. Okay, they corresponds to the infrared region. So here students, if the value of n is equal to 3, that means if the electrons is jumping from higher energy to the third shell, from third shell to upwards, that is towards the fourth shell, fifth shell, sixth shell, all are IR regions, infrared regions. Okay, if the electron is jumping to the second shell, then the color is obtained. That means it lies in the visible region. And if the lines are produced when the electron jumps from higher energy to the first shell, then it is UV region. So we have Lyman series is UV region, Balmer series is visible region, Passion, bracket, Fund and Humphrey series are IR region, infrared region. These are the things you have to understand. Okay, and let me also give you the values of the energies. Here the first shell consists of minus 13.6 electron volt, that is the energy, and the second shell has an energy of minus 3.42 electron volt. The third shell has an energy of minus 1.51 electron volt, and fourth shell is minus 0.85 electron volt. Fifth shell is minus 0.545 electron volt. Sixth shell is minus 0.386 electron volt, and the last shell is minus 0.287 electron volt. Okay, so this is the energy of each shell. And also you can find out the energy difference between the shells. First shell and second shell, you can just subtract it and find out the value, and we know that the value will be 10.2 electron volt. Similarly, you can subtract and find out what is the value. Okay, that will be of great help for if you know that values of the energy gaps. Okay, now we will move on to the next one. So here it is. So I have given you the Lyman series. The Lyman series lies in the region of ultraviolet. It gives the lines which are of ultraviolet. And what is the N2? N2 is the shell from which the electron jumps. Okay, so it can be 2, 3, 4, 5, 6 and 7. And to where it jumps, if the electron is jumped to 1, then that particular line corresponds to the Lyman series. If an electron jumps to 2, then that particular line corresponds to Balmer series. If the electron jumps to 3, then that particular line corresponds to Paschen series. Likewise it goes. So if N1 equal to 1, then it is Lyman series. If N1 equal to 2, then it is Balmer series. N1 equal to 3, it is Paschen. N1 equal to 4, bracket, and N1 equal to 5, it is Pund. So from each lines or by knowing the value of N2, you can find out the number of lines. So we know that the maximum value of N2 is 7. So how many lines Lyman series lines can be obtained? So we can use this formula N2 minus 1, that means 7 minus 1, that is equal to 6 lines. Okay, 6 lines are in total present in the Lyman series. And 7 minus 2, that means 5 lines are present in Balmer series. And 7 minus 3, this is the maximum. Okay, if the question is asked find out the number of lines when an electron jumps from 4 to 1. So from 4 to 1, how many lines are present? 4 to 1, 3 to 1, 2 to 1, that is 3 lines are present. Okay, that means you can use this formula 4 minus 1, you will get the answer as 3. That's how you have to do it. So N2 minus 4, here we know we are calculating the maximum value. Okay, so N2 is 7, 7 minus 4 equal to 3, and 7 minus 5 equal to 2. These are the different values or the number of lines present in each series. So this value of 7 can be changed according to the question asked. If they are asking you, if N2 is given as 6, then it is 6 minus 1. If N2 is given as 3, then it is 3 minus 1. So you should be careful. It is not always the number of lines is 6. The maximum number of lines is 6. Okay. But if the question is asked when the electron jumps from 4 to 1, how many number of Lyman series is obtained, or how many number of lines of Lyman series is obtained, then 4 minus 1, 3 will be the answer. So you have to be careful about that. Okay. Yes. Now we'll move on to the next one. So for any series, the first line is called as the alpha line, and the second line is called as the beta line, and the third line is called as the gamma line. Say, if I say that if electron jumps from 4 to 1, if electron jumps from 4 to 1, see 1, 2, 3, 4. So this is n equal to 1, this is n equal to 2, this is n equal to 3, and this is n equal to 4. How many lines are possible? Yes, from 4 to 1, if it jumps from 4 to 1, an electron or the electrons jumps from 4 to 1, one line is obtained from 4 to 1. Okay, from here we have to understand there are lots of electrons present here, and some electrons will be present over here in the third, and some electrons will be present over here in the second shell. So now the second jump is from 3 to 1 and the third jump is from 2 to 1. That means from n to 1, how many lines can be formed? 3 lines can be formed. That we have just studied the formula n2 minus 1, that is 4 minus 1 equal to 3 lines. Okay, the first line is from 4 to 1, that is our alpha line. The second line is from 3 to 1, that is beta, and the third line is from 2 to 1, that is gamma. Okay, so there is a confusion for students that if an electron, if it said that the electron or the emission spectrum from n2 equal to 4 to 1, how many lines are formed? Students will write 1. From 4 to 1, one line. No. You have to understand there are a lot of electrons standing in 4. So some of the electron will straightly jump to 1 and some will jump to 3. Some will jump to 2. So now the second possibility is that from 3 there is a straight jump to 1. So that will be the second line. And from 2 there will be a straight jump to 1, and that will be our third line. So there always be 3 lines in this case in the Lyman series. The first line will be from 4 to 1, that is alpha. Second line will be from 3 to 1, that is beta, and third line will be from 2 to 1, that is gamma. Hope this is clear. Now the next one is, we are going to discuss about the calculation of number of spectral lines. Okay, calculation of number of spectral lines or the total number of possible lines. Total number of possible lines. So here is the formula. Total number of spectral lines equal to, total number of spectral lines equal to n2 minus n1 into n2 minus n1 plus 1 divided by 2. See, if you use this formula, you will be getting the total number of spectral lines. It's not like how many lines are present in Lyman, Balmer, Paschen, not like that. It is a total number of lines. That means the total number of lines present in Lyman plus Balmer plus bracket plus fund plus Paschen, like that it goes. So total number of spectral lines means you have to use this formula. Okay, if I say if n2 is equal to 7, n2 equal to 7 and n1 equal to 1, okay, what are the total number of spectral lines? They are only asking the total number of spectral lines, not asking about the number of lines present in Lyman series. No, they are asking the total spectral lines. So what you have to do, if they are asking about the number of lines in the Lyman series, what you have to do? You have to do just n2 minus 1. If they are asking about the number of lines in the Balmer series, what you have to do? You have to do just n2 minus 2. Okay, but here they are asking you about the total lines. So total lines is equal to 7 minus 1 into 7 minus 1 plus 1 divided by 2. You will get the answer as 6 into 7 by 2, that is 42 by 2 equal to 21 lines. So let's check this whether it is correct or not. From here we got, in the Lyman series we got 1, 2, 3, 4, 5, 6 lines. Okay, 6. In the Balmer we got 5. In the Paschen we got 4. In the bracket we got 3. In the fund we got 2, and in Humphrey we got 1. 6 plus 5, 11. 11 plus 4, 15. 15 plus 3, 18. 18 plus 2, 20. 20 plus 1, 21. See, the total lines, instead of drawing all the lines and calculating, just follow this formula. You will get the answer in just seconds, right? We got the answer 21. We also did it the same way by counting each lines present in the each series. Okay, hope this is clear for you, students. Now in the next one, see, so already we have done the example. Now number of spectral lines, if you are asked to find out the number of spectral lines which falls in a particular series, the previous equation helps us to find out the total number of spectral lines. Now here we are discussing only about the number of spectral lines which is present in each series. That means in Lyman series how many lines are present, in Balmer series how many lines are present. That's what we are discussing here. So number of spectral lines which falls in a particular series is equal to, just you can write it as n2 minus n1, that's all. If for the Lyman series n1 is equal to 1 for Lyman series, for Balmer series n1 equal to 2, like that it goes. n1 equal to 3 for Passion series, n1 equal to 4, n1 equal to 3 for Passion series, n1 equal to 4 for Bracket series, n1 equal to 5 for Fund series, and n1 equal to 6 for Humphrey series. Okay, so each series, if you are asked to find out the number of spectral lines present in each series, use this formula n2 minus n1. Or if you are asked to find out the total number of spectral lines, then you have to use this formula, that is n2 minus n1 into n2 minus n1 plus 1 divided by 2. Hope this is clear, students. Okay, now let's do this problem. In hydrogen spectrum, if electron moves from 6th to 3rd orbit, see, from 6th to 3rd orbit by transition in multi-steps, then find total number of spectral lines. So in order to find the total number of spectral lines, we know the formula n2 minus n1 into n2 minus n1 plus 1 divided by 2, right? So just substitute the value. n2 is 6, n1 is 3, 6 minus 3 into 6 minus 3 plus 1 divided by 2. So here you will be getting 3 into 4, 12 by 2, that is equal to 6 lines. So in total there will be 6 lines present. Okay, now you have to find out how many, the number of lines present in the UV region. See, UV region means n1 should be what? n1 should be 1, right? For UV region, we know that it should be in the Lyman series, lies in the UV region, or the Lyman series lines are UV lines. So for obtaining Lyman series, we need n1 equal to 1, but here the electrons is only jumping to 3. The electron is not jumping to the first shell or the first orbit. So how many number of UV lines are present? Yes, 0 lines. Now number of visible lines. So in order to get the visible lines, the n1 should be 2. That is the Balmer series. Here the electron is jumping from 6 to 3. It is not jumping to 2. That means there are no visible lines. So that is also 0. Now you have to find out the number of lines in Passion region. Passion means n1 is equal to 3. That means here you can find out how many number of lines. We know that it is n2 minus n1, that is 6 minus 3 equal to 3. Right? Now number of lines in Bracket region. In Bracket region we know that n1 is equal to 4. So what is the number of lines? 6 minus 4 equal to 2. Now in the case of Fund series, we know that n1 is equal to 5. That means 6 minus 5 is equal to 1. Here they are asking about the number of lines in the IR region. See, we know that in the IR region, after Balmer, everything is in IR. That means here 3 lines in IR, here 2 lines in IR, here 1 line in IR. So totally there are 6 lines in IR region. Hope that is clear, students. Okay, now we'll move on to the next one. A certain electronic transition from an excited to ground state of hydrogen atoms, gives 5 lines in UV region. How many lines does this transition produce in IR region? So here they have given that there are 5 lines. Okay, so we do not know what the value of N2. If you know the value of N2, then only we can find out the number of lines present in the IR region. Okay, but in order to find out the value of N2, we are given with certain data. That is, it gives to the ground state means what? Ground state is N1 equal to 1. 1 is the ground state. Second is the excited state. First excited state, then the second excited state. These all we have discussed in the previous lesson. Okay. Now, when the electron jumps from N2 to N1 equal to 1, we got 5 lines. That means N2 minus N1 equal to 5. How did I got that? Because we know the relation. In order to find the number of lines in Lyman series or any other series, we only have to do what? N2 minus N1. So here the value N2 minus 1 equal to 5. That means N2 is equal to 6. So we got the value N2 equal to 6. Okay. Now number of lines in passion, bracket and fund is the only thing we have to find out. So number of lines in the passion, number of lines, passion lines, how much it is? For passion we know that N2 is equal to, N1 is equal to what? N1 is equal to 3. So we know that 6 minus 3, that is equal to 3. Now number of bracket, because we know that passion, bracket and fund are the 3. Humphrey cannot be obtained in this because it is jumping from 6. Okay, when electron jumps from 7 to 6 only we get a Humphrey. That's why I am not taking Humphrey. Okay, so only passion, bracket and fund is required. So for bracket it is the electron should jump from 6 to or should jump to 4th shell. So that means 6 minus 4. N2 minus N1 is equal to 6 minus 4, that is 2. Now number of fund, number of lines in fund, that is 6 minus 5, that is equal to 1. So in total we get the value as 6. So there are 6 lines which are present in 6 lines in IR region. We obtain 6 lines present in IR region. Hope this is clear, students. Okay. Now we will move on to the next one. Now let's discuss about the absorption spectrum. So for the absorption spectrum, you have to understand that absorption spectrum takes place when the electron from the ground state absorbs certain energy and when it moves to this and it moves to the second or the higher energy shells. That's when we obtain the absorption spectrum. Okay, so let me again draw 7 lines which corresponds to 7 periods or 7 shells. 5, 6, 7. Okay, so I'll write it as K, L, M, N, O, P and Q. Okay, now we know that this is N equal to 1. The electron will be present, always will be present here, because we are dealing with the hydrogen spectrum. So in hydrogen spectrum, electron will be present in 1, especially in the case of absorption. Absorption spectrum is when the electron absorbs energy when it is in the ground state and it excites to a higher state. But in the emission spectrum, we obtain the spectrum when electron from higher state jumps back to the first one. Okay, so that's the difference. So absorption spectrum is always obtained when electron from first shell jumps to the other shells. Okay, so from 1 to 2 it can jump. If it jumps to from 1 to 2 we obtain 1, and from 1 to 3 we obtain another line. From 1 to 4 we obtain another line. So here you have to understand one thing, that is, in the case of absorption spectrum, we do not get a line absorption spectrum from 2 to 3 or 3 to 4 or 2 to 4, like that we do not get. This is wrong. The absorption spectrum is only obtained when the electron from the ground state jumps to the higher state. Other spectrums are not considered as the absorption spectrum. That means when the if the electron is present in the second shell, then it absorbs energy, and when it gets excited to fourth shell, that is not absorption spectrum. Absorption spectrum is only considered when the electron is in the ground state and then it jumps to the higher energy shells. So this is the important point you have to understand, because in the emission spectrum, it can jump from anywhere. From the higher state, it can jump from 6, it can jump from 5, it can jump from 4, 3, 2, etc. But in the case of absorption spectrum, the jumping towards any shell is possible, but the jumping should be from 1. It can jump from 1 to 7, it is possible, we get the absorption spectrum. It can jump from 1 to 6, it is possible, it can give us the absorption spectrum. But the jumping from any other shell, that is from 2 to 3 or 3 to 5 or 4 to 6, that is not possible. 1 to 5 possible, 1 to 6 possible. That is considered as the absorption spectrum. So whenever the absorption spectrum is given, you have to, one thing is clear, that is N2 will always be equal to 1. That's fixed. Okay, hope that is clear. Now, in order for an electron to jump from first shell to the second shell, how much energy it should absorb? We know that the energy gap here is 10.2 electron volt. And for the electron to jump from 1 to 3, it requires an energy of 12.9. From 1 to 4, it requires an energy of 12.75. And from 1 to 5, it requires energy of 13.06. See, there is an energy gap. This energy gap, see, this is an energy gap, and this energy gap is almost around 1.89. This energy gap is 1.89. Can the electron absorb this energy and jump from 2 to 3? No, that is not possible. Electron can only absorb 10.2 electron volt, or it can absorb 12.9 electron volt, or it can absorb 12.75 electron volt, or it can absorb 13.06. That's what you have to understand. That's the important point you have to remember. Okay, I already told the absorption spectrum is only obtained when the electron from the first shell, jumps from the first shell. That's what it is important. So the electron can only absorb these energies, not any other energy can be absorbed by the electrons. Hope that is clear. Now let's see an important note. The transition in absorption spectrum of hydrogen always occur from the ground state only. That's what I have told. That means only that photons are absorbed which have energy 10.2 electron volt, 12.09 electron volt, or 12.75 electron volt. I told you the same thing. It can either absorb energies of photons of energy 10.2, 12.9, 12.75, or 13.06. These are the energies of the photons which can be absorbed by the electrons. But when, you have to understand this is another important concept, but when an electron having energy more than 10.2 electron volt strikes the hydrogen sample, then it will be absorbed as extra energy and may be converted into kinetic energy. That means, if I say instead of 10.2 electron volt, we provide 11.3 electron volt. Say that 11.3 electron volt, a photon is approaching an electron with a energy of 11.3 electron volt. Does it absorb that? Yes, it will absorb. It will absorb 10.2 electron volt and it gets excited to the energy shell, and the rest, that is 1.1 electron volt, will be utilized as the kinetic energy to move in that shell. So that kinetic energy, that is 10.2, 11.3 minus 10.2 is 1.1. That much energy or kinetic energy is utilized to move. Actually, this is what happens in the case of photoelectric effect. When the sunlight strikes a particular metal, the electron absorbs the required energy to excite to the out of the metal, and it absorbs certain energy and it excites to out of the metal, and the remaining energy or the excess energy is utilized for the movement of the electron within the solar panel. Hope that is clear. And that particular energy is called as the kinetic work function. That is called as the work function in photoelectrical cell. Okay. So if 10.2 electron volt strikes on the hydrogen sample, then that particular electron volt of energy is absorbed and it jumps to the higher energy shell. And if excess energy is present, that is if there is greater energy is present in the photon, that is if the photon contains energy greater than 10.2 electron volt, then the excess amount of energy is utilized as a kinetic energy for those electrons to move within the cell or within the shell. Now, number of absorption is equal to number of Lyman series minus 1, right? Number of Lyman lines, that is equal to N2 minus 1. So, number of absorption lines means it is equivalent to number of Lyman series, because we know that here the N1 is equal to 1. It always jumps from 1 to 2 or 1 to 3 or 1 to 4, likewise we get. So, all the absorption lines are what? Lyman lines or Lyman series. So, it's easy to find out the number of absorption lines. The equation is N2 minus 1. Now, in the question, here in an atom, 5 orbits are present. Okay. Then calculate the number of emission lines and absorption lines formed in the spectrum. So, number of emission lines, we know that number of emission lines, what is the formula? Number of emission lines is equal to N2 minus N1 into N2 minus N1 plus 1 divided by 2. So, N2 here is 5, N1 is 1, okay, that is the maximum. So, 5 minus 1 into 5 minus 1 plus 1 divided by 2, that is 4 into 5 by 2, that is equal to 10 lines, 10 emission lines are possible. Now, you have to find out the absorption lines. Number of absorption lines is equal to number of Lyman lines, right? What is Lyman lines? That is equal to N2 minus 1. N2 here is 5. So, 5 minus 1 is equal to 4. So, the absorption lines is equal to 4. Now, let's move on to the next question. If 9.9 electron volt energy is supplied to hydrogen atoms, so we are providing energy of 9.9 electron volt energy is provided to hydrogen atoms. The number of spectral lines emitted is equal to, see, the electron can only excite if we give them a minimum of 10.2 electron volt. If 10.2 electron volt is given, then the electron will jump to the second shell. Okay. See, here you can see that we have explained it very well. Here, that is, the electron can only jump to the second shell if you are providing an energy of 10.2. If you are providing an energy of 12.9, then the electron can jump from one shell to the third shell. If you are providing 12.75, then it can jump from 1 to 4. Okay, if you are providing 13.06, then it can jump from 1 to 5. But here in the question, they are only providing an energy of 9.9 electron volt. That is not enough for an electron to jump to any of the shell. So, the number of spectral lines emitted will be equal to 0. Option A is the right answer. Now, we will move on to the next question. If a photon of energy 14 electron volt, see 14 electron volt is incident on an atom, what is true? See, we know that if 14 electron volt is incident, you can see here there is an energy of 13.6, right? And the maximum energy, the next energy will be the maximum energy difference between the 7th shell and the first shell is 13.6. Here it is 13.06, but the maximum energy will be 13.06 electron volt. What does this indicate? You have to understand that if you are providing an energy of 13.6 electron volt, then that particular electron can be ejected out of the atom. That means Q is the last shell. So if you are providing an energy more than 13.6, that means you can eject the electron out of the atom, because the 7th shell, that is normally considered as the last shell. Okay, the 7th shell, we know that infinite shells are there. Even then, we are considering the 7th shell as the last shell, and the energy difference between the 7th shell and the first shell is 13.6. So if you are providing an energy of more than 13.6, then the electron will move outwards or out of the final shell, valence shell. That means the atom will get ionized if you are providing any energy greater than 13.6, right? So from this question, you are providing 14 electron volt. That means 13.6 electron volt. What is the difference between that? 14 minus 13.6 electron volt means it is 0.4 electron volt, right? So 0.4 electron volt will be considered as the kinetic energy. And what happens is that if you are providing any energy that is greater than 13.6, means the atom will get ionized. That means the electron will completely move out of the atom. So here you can say that the atom will be ionized and electron will have a kinetic energy of 0.4 electron volt. Option 2 is the right answer. Now let's see. Last question. An electron of energy 10.8 electron volt is incident on an atom, on a hydrogen atom. Then we know that first it is 10.2 electron volt. From first shell to second shell, you require 10.2 electron volt. If the electron absorbs 10.2 electron volt and it gets excited to the second energy shell, now it has 0.6 electron volt of kinetic energy, which makes the electron move in the second shell. So the option 3 will be the right answer. That means 10.2 electron volt of electron would be absorbed by hydrogen atom and it would come out with 0.6 electron volt energy. Yes, so we have discussed about the spectrum. We have discussed about both the spectrum, that is the absorption spectrum as well as the emission spectrum. Hope this is clear for you. Hope you have enjoyed it and understand these questions are the model questions that can be asked for the exam from these sections. If you can successfully do these problems, then I can guarantee you can easily answer any questions asked from this section. Okay students, hope it is clear for you. If you have any further doubts, you can just give it in the comment section or you can just post in the Telegram group. I'll be so happy to clarify your doubts. So hope this session was fruitful to you and thank you for watching and all the best for your exams. Thank you students.